Hello guys, my name is John Michael A. Reyes and I'm currently a second year BSIT student in Batangas State University, and we're here to discuss the summary of the Chapter 8 Subnetting IP Networks. So it is all about the addressing of the IP, or giving the end devices, intermediary devices, and routers or other stuff some IP addresses. And Chapter 8 Subnetting IP Networks, and Chapter 8 Section and Objectives Introduction. 8.1 Subnetting an IPv4 network. It explains how subnetting segment network to enable better communications. Examine how to calculate IPv4 subnets for a prefix 24 prefix. Examine how to calculate IPv4 subnets for 16 and 8 prefix. Given a set of requirements for subnet, implement an IPv4 addressing scheme. Explain how to create a flexible data scheme using variable length subnet mask or VLSM. Then addressing scheme, implement a VLSM addressing scheme, design consideration for IPv6. Then explain how to implement IPv6 address assigned in a business network. Then 8.4 is the summary. Let's proceed. 8.1 the network layer protocol. Network segmentations. Broadcast domain. Each router interface connects a broadcast domain. Broadcast domain are only propagated within its broadcast domain. In broadcast domain, when you send it in broadcast domain, it somewhat sends all the information to all host devices, and everyone has its own broadcast domain in a topology or system. Then problem with large broadcast domains: slow network operation due to significant amount of broadcast traffic. As you can see, if you have so many end devices and intermediary devices, all it will buffer slow because you have so many of it, because it has more bytes to conquer and read. Then slow device operation because a device must accept and process each broadcast packet, just I've said. Then reason for subnetting: it is a solution reduce the size of the network to create a smaller broadcast domain. Then because each broadcast domain connects to a different router interface, each domain needs its own network address space. Then the process of breaking an address range into smaller address spaces is called subnetting. And network administrators can group device into subnets that are determined by location, organizational units, or device type. Then after this, you can see in here there are figures. Then octet boundaries. Octet boundaries are somewhat in 8, 16, or 24. Subnets can be created based on octet boundaries. As you can see in here, it is somewhat an octet. This 8-bit in here. Then subnetting on the octet boundary, also known as IPv4 classes. Then use the octet boundaries to separate network from the host. As you can see in here, this one separates the network from the host. Then classless subnetting uses address bits to separate network from host, allows more flexibility, still like this one. As you can see here, there are 126 hosts because of 2, 4, 8, 16, 32, 64, and 128. Then minus 2 for the broadcast address and the other stuff. Then so only classless subnetting in here, 128. So if you have 128 subnet mask, you will list down all ones. You will list down 25 ones. Then after that, it will be 0, number of subnet, it's 2 because as you can see in here 128, there will be only 2 subnets that can be created because you can go or pass through 0.255. Then subnetting an IPv4 network, creating two subnets is somewhat, subnet mask is applied to 192.168.10.0, creates two equal subnets, each one with 126 hosts, because the first one is somewhat the 192.168.1.0, then the second one would be the 192.168.1.128. Then subnetting formulas, and the subnetting formula would be use 2 and 2 raised to n to calculate the subnets, then use 2 raised to h minus 2 to calculate the host numbers, then n is the number allocated to the network portion of the address, and h is the number allocated to the host portion of the address. And creating 4 subnets, the subnet mask of /26 to 192.168.1.10.0 creates 4 equal subnets with each one with 62 hosts, because it will be divided or plus with 64. The first one is 192.168.10.0, then the second one would be 192.168.10.64, then the second one is 192.168.10.128, then 192.168.10.192, then after that will be nothing, because if this plus 64 I think, or 254, then after that, sorry for my cold, sudden subnetting an a /16 and /8 prefix, created subnets with a /16 prefix, a subnet mask of 16 applied to 172.16.30 to create a host of 65,534 hosts, a subnet of /18 of 172.16.32.0 creates 4 networks with 16,382 hosts in each network, then a subnet of /22 applied with 172.16.32.0 creates a 64 network with 1,222 hosts in each subnet. As you can see, if the networks go up, the host goes down. Then creating 100 subnets with a 16 prefix /16, a subnet mask of 23 applied to 172.16.32 will create 128 network with 510 hosts in each network. The calculating the host, just to 2 raised to h to calculate the number of hosts, h is the allocated host portion of the addresses, then creating 1000 subnets with a /8 prefix, a subnet mask of 18 applied to 20.0.0.0 creates 1,224 network with 16,382 hosts in each network. Then after that, subnetting to meet requirements, subnetting based on host requirements to consider when planning subnets, the number of host address required and the individual subnets needed. Then after that, the subnetting based on network requirements, the IP range, then thinks of a 7 department where each department must have its own subnet, then host per subnet, while secondary is also important. Then network requirement, example, these are the range. As you can see, 7 subnets must be created. Each department will have no more than 29 hosts. Then a subnet of 27/27 applied to 200.42.98.0/24 creates 8 networks with 30 hosts in each network. Then, as you can see, it accommodates the requirements. Then, benefits of BLSM: traditionally submitting host address, submitting based on classes is not flexible, result in wasted addresses. BLSM, by varying the mask of administrator, has more control, less waste than basic BLSM. A subnet mask of 30 applied to 200.42.98 creates a network with 2 hosts in each network. Then the network 200.42.98.0/30 would be perfect match for a serial link. Then VLSM practice considered 2 routers connected by a serial link. Router would be 200.40 and router B would, then as you can see, it just go up by 1 because it is /30. Then and /30 is the magic number for that is 100. Yep. Then addressing scheme, structure design, as you can see here, network administrate, planning, then size, and other stuff, planning to address the network, prevent duplication of address, monitoring security and performance, provide access control, assign address to device. Different device needs also may also impact the scheme and other stuff and users. And 8.8.3, the structure design, the IPv6 global unicast address. The IPv6 global unicast address normally consists of /48 routing prefix and a 16-bit subnet ID and 64-bit interface ID. Submitting using subnet ID, the subnet ID provides plenty subnets and host support in one subnet. The subnet ID alone allows for creating up to 65,536/64 subnet. Then IPv6 allocation address space is not a concern in IPv6 administrator can concentrate on designing a logical scheme. Then the summary of this is implements an IPv4 scheme to enable end-device connectivity in a small to medium-sized business network. Then given a set of requirements, implement VLSM addressing scheme to provide connectivity to end user in a small to medium-sized network. Explain designs consideration for implementing IPv6 in a business network. As you can see in this chapter 8, it is the most important part is the VLSM, because in the VLSM you can accommodate, or in VLSM the IP address would be fine or in a order because it would be entangled with each other, and you will maximize the network addresses and the host portion for it. Then that's all for chapter 8. Thank you for listening.